Hello everyone, welcome back to the channel. The company Revopoint sent me the MetroX 3D scanner for testing. In today's video, I will show you how this amazing device can be used from an amateur perspective. The package was really well prepared. Inside, I found a multilingual user manual, a calibration board, the 3D scanner itself, a tripod mount, and a set of cables with a power supply, a test figurine, and a well-designed tripod. There was also a rotating turntable with multiple degrees of freedom. In the second package, there were adhesive markers, and magnetic markers mounted on rods. The magnetic markers came in the form of spheres, hemispheres, and cones. The turntable itself is turned on manually. However, you can use the application provided by the manufacturer to control the tilt settings of the turntable from a smartphone. It reacts with a slight delay, but it is still possible to adjust it during scanning. I covered the element to be scanned with a special spray, which disappears after some time and helps the scanner capture surface details more accurately. In my video, I want to show that I worked with elements that are very small for this type of scanner. The manufacturer indicates that the recommended object size for scanning is around 10 by 10 centimeters. However, I want to prove that such small elements as die-cast car hood and doors can successfully be copied using this device. The scanner software is very clear, and even people who have not had contact with this type of equipment before are able to manage the scanning process. I specifically chose small elements to test different capabilities of the scanner. At the beginning, I worked quite chaotically. However, each next attempt turned out better. Having a live preview on the laptop screen, I tried to move the scanner in such a way that the tracking accuracy bar stayed within the green range. During the rotation of the turntable, the scanner automatically captures and saves consecutive frames. Their number is shown in the bottom right corner of the screen. It is the operator who decides whether the number of captured frames is sufficient to achieve the desired scan accuracy. The manufacturer has very precisely defined the hardware requirements for running the MetroX. A weaker computer may still connect to the scanner, but it may not be able to process and save all captured frames, resulting in lower detail quality. I also noticed that when scanning small elements, it is very helpful to place them on a larger object that is scanned together with them, improving tracking stability. You can also add markers, which help the scanner maintain proper positioning during scanning. In this case, I placed the hood that I wanted to copy on a cardboard box, which absorbs the laser light very well. And I was able to achieve a surprisingly accurate scan of the hood itself. Later, it was enough to fill small missing areas. The software handles this very well and allows you to separate the desired object from the box, which is not needed. The cutting process itself is very intuitive, and anyone who has ever used graphic software will easily understand it. Each operation takes a moment to process, but the program allows you to go back if a cut does not turn out as expected. As you can see, the scan turned out very well. The only difference from the original is that the copy made on a resin 3D printer is much lighter than the original metal hood. For comparison, I show placing both parts on a Ford Capri model. After placing the original hood, I then installed the copied one. Despite the natural shrinkage of resin during printing, in this case, the final result is very accurate. I did a similar process with the doors for this model. Before scanning this element, I covered it with spray that improves scan quality. I started scanning the doors in the same way as the hood, on a cardboard box, but they turned out to be much more demanding. In the upper part, they have a very thin window frame, which made it difficult to capture a consistent result across the entire surface. Attempts to fill missing areas caused the software to incorrectly fill the entire window opening, which was not desired. I scanned the doors using very high accuracy settings. I tried different scanning modes and techniques available in the Revo Point software. However, I concluded that for the doors, I need another attempt using magnetic markers to improve tracking. At this point, I will add that this scanner has a practical advantage, as it is equipped with rubber pads that allow it to be safely placed on a flat surface between scanning sessions. This element turned out to be important. After setting up a stand with markers, I started scanning the doors again. With the markers positioned higher above the scanned object and scanning by hand, I was able to achieve different angles and positions of the scanner relative to the doors, capturing a more complete model and reducing missing data. It is impressive how such an irregular shape transforms into an almost perfect digital model of the doors. After performing multiple scans and reaching over 1,700 frames captured from different positions, I proceeded to cut out the object in the same way as shown earlier with the hood. In this case, the missing areas were very small, and I was able to easily fill and clean them. The scanned model was then further cleaned in Blender, which is a free software tool. Now you can see how the scanned doors compare to the original ones installed at the beginning. After painting, the difference is practically unnoticeable. You will definitely see more uses of this scanner in my future videos. That's it for today's video. Don't forget to like, comment and subscribe, and I'll see you in the next one.